Welcome to qnawire.
In this problem, let's see, we have another simple Rankine cycle with steam. This time we have a saturated or a two-phase fluid coming out of the turbine. Again, the low pressure is down here at 50 kilopascals. High pressure is at 6 megapascals. Again, we're told that the rate of heat transfer into the into the system is 40 megawatts. So we can get the enthalpy on the specific volume at 1, find the energy that it takes the pump to pump that up to from 50 to 6,000 kilopascals, and then energy balance in the pump gives us the enthalpy exiting the pump. So then we know we're given the temperature here, which is 600 degrees C, and we know the pressure, so we can get the enthalpy and the entropy. It's an isentropic turbine, so we can know that S4 is the same as S3, and we know P4, so we can get the quality factor, and we can get H4. Now we have now the enthalpy at all of our inlets and outlets, so we can get the specific heat going in, which is just H3 minus H2. The specific heat going out, which is let's see here, H4 minus H1. And from this, we can get the efficiency, which is just 1 minus the ratio of Q out over Q in. And that winds up being about 35%. And now they asked us a little follow-up question about if the liquid enters the pump at a 11.3 degrees cooler than a saturated liquid at the condenser pressure. So what we can do here is we can also figure out what the saturation temperature is at the inlet here, and that turns out to be 81.3 degrees C. So we can subtract off our 11.3, and we get that it enters the pump at 70 degrees C instead of 81.3. And so now we have a pressure and a temperature at 1. So we can see that the enthalpy has now gone down somewhat. The specific volume has gone down a little bit. So the work going into the pump has gone down a little bit because this is a little bit less than this. The enthalpy coming out of the pump has gone down quite a bit. And so we have the rate of heat transfer in. The specific heat transfer in is a little bit higher, right? So because H2 went down, so we have H3 minus H2. So this is higher than it was before. This is also higher than it was before, because H1 is now down. And in the end, we wind up with a slightly lower thermal efficiency of about 34.5%. So it's not good to have our feed water super cooled at this point. We'd like it basically just to be on the saturation, have it just be a saturated liquid.